Hey geometry team, and welcome to Unit 6, and we are having another day of practicing doing proofs using CPCTC, using corresponding parts of congruent triangles being congruent. And so if you have not already done this worksheet, you are doing this now, and you get a chance to have me walk you through a couple of them before you attempt it on your own. So looking at this first proof here, you have two givens. You're given that segment BC is congruent to segment AD and segment AB is congruent to segment CD. Anytime you have givens, you want to make sure to immediately mark them on your picture. So I'm given that segment BC is congruent to segment AD. So I'm going to mark it with those green marks. And then I'm given that segment AB is congruent to segment CD, and I'm going to mark it with those orange marks. Now I'm ready to do my proof. So I'm going to take those givens and put them again into the two columns of my proof. So I'll have the BC is congruent to AD, which was given, and I have that segment AB is congruent to segment CD, which is also a given. Now, we are looking to prove these two pieces congruent. And I have no way of proving that this angle A and this angle C are congruent based solely on what they told me. But we have just been taught an idea that corresponding parts of congruent triangles are congruent. And so if we can just prove these two triangles congruent, then we can say that angle A is congruent to angle C. So let's see if we can prove this triangle on the right congruent to this triangle on the left. Well, we already have a side on each of those congruent, and we already have another side on each of those congruent. So if I can just prove one more thing, I only need three things to prove triangles are congruent, then I'm made in the shade. And so I look, and we get really excited when our triangles are touching because we can use the shared side and say that it's congruent to itself. BD is part of the left-hand triangle, and BD is part of the right-hand triangle, and conveniently, BD will be congruent to itself because of our reflexive property, which gives me a third side of those triangles being congruent. So now I'm really excited because now I can say that these two triangles are congruent. But I have to be careful. If I'm going to say that triangle ABD is my first one, then when I name the second triangle, I have to name the letters in the right order. So since I started with angle A, the corresponding part in this one is angle C. So I'd start with angle C. Then I go across this orange 2-mark segment to B. If I go across the 2-marked orange segment here, I end up at D. So it'll be D next. And then from B to D, I slide down the diagonal. So in this other triangle, I'm going to go from D and slide up to B. And I have my two triangles. And that is according to side, side, side congruence. Well, now that I have that the triangles are congruent, now I know, according to CPCTC, that all of their parts better be the same. So these two little angles better match up, and these other two little angles better match up. And so now I can say that angle A is congruent to angle C using CPCTC. Okay? And so anytime we do these, we're going to just look to prove the triangles congruent so that then we can prove parts congruent. So moving up to this second example now, I'm given that angle ADB is congruent to CDB. Well, ADB is this guy right here, and I've been told it's congruent to this guy right here. So I've marked them in the picture, and now in my two-column proof, I'm just going to remind myself that I was given those angles. And ooh,